Okay, minasan, konnichiwa, Zamurai Engineer desu. So we are again here live at Taguig City University. So let us continue with the next module about load combination, but now we will talk under the approach of ASD. So specifically, allowable stress design. Again, let's start with the objective of this course. This course will provide fundamental concepts, principles, theories, under structural analysis and design of steel elements in an structure. So we have again the main topics. We are on the second major topic, under which we are on the module number 8, part 3. So let us immediately proceed to the load combination that is used for allowable stress design. So according to the code AISC 360-16, so these are the following formulas that we have to use when we are going to calculate the maximum load required strength. Okay, so let us mention it one by one. Equation number 1, you have to memorize it this way. Dead load. Equation number 2, dead load plus live load. Equation number 3, dead load plus roof live load or rain load or rainfall load. Equation number 4, dead load plus 0.75 live load plus 0.75 roof live load or rainfall load. And equation 5, dead load plus 0.6 wind load or 0.7 earthquake load. Take note, there are differences of this set of equation from the LRFD set of equation. Take a look for the, in particular, we have 0.6 times wind or 0.7 times earthquake. Okay, so that is number 5, and what is number 6? Letter A, so dead load plus 0.75 live load plus 0.75 times 0.6 wind plus 0.75 times roof live load or rain load. And letter B, dead load plus 0.75 live load plus 0.75 times 0.7 earthquake load plus 0.75 snow load. So we do not have that, so we can immediately disregard this. However, I don't disregard this right away because our author is an American author, or maybe sometimes we do not have to use this in our engineering career in our country, but by consideration of future problem solving. Okay, so we are using a book with American author that uses snow load. We have what? probably Board of Civil Engineering examiners that may copy a problem from foreign authors that may have snow in their country. So that's why I do not totally take that out from our consideration, because for our future reference at least. But in our country, NSCP do not provide for snow load. Take note. Okay? NSCP would be our main reference law. Okay? So equation number 7, 0.6 dead load plus 0.6 wind load. And equation number 8, take note, we have now 8 equations. Previously on LRFD, we have 7 equations. Okay? So equation 8 is 0.6 dead load plus 0.7 earthquake load. Okay? So let us proceed with the comments and explanation. In the 7th and 8th equations, the full dead load is not used. What is used? Okay, so there is no full dead load, meaning only 0.6, only 60% of dead load is used. Okay, why? Okay, the variable loads, wind and earthquake, have lateral components. That is the reason, and tend to cause structure to overturn. If we overturn the structure again for the end time, I will say that one part of the whole structure would experience compression, and the opposite part would experience tension. On the other hand, the dead load is a gravity load which tends to prevent overturning. Therefore, it can be seen that a more severe condition occurs if for some reason full load is not present. Okay? Because since the gravity load would negate the effect, the harmful effect of wind and earthquake. Okay? So we need heavy structure so that it would not roll down. So it will not roll. It may fall, but rolling down on one side. Okay, overturning. That is our technical term. Overturn. That is the term we are using in what? Hydraulics for design of a dam. So overturn of the dam. Okay. So same is true with building. If the building overturns, okay, so it sort of rolling. Okay, so there are parts which would experience compression and parts would experience tension. So in general, the AISC specification provides what the AISC deems to be the maximum loads to be considered for a particular structure. This I already explained about. Okay. So I noticed there have been very good group of students. There are no questions, and happy birthday. Shout out to our secretary, Daniela Kagia. Okay, so happy birthday. So congratulations for celebrating your 17th birthday. Okay? 17 or 16? Anyway, just the same, happy birthday. So let us take example 6, okay, to apply our knowledge. Okay. So applying the ASD load combination as recommended by IISc, determine the load to be used for the roof system of example 5. Okay, so do you remember the load for example 5, where the load is equal to 4? Okay, load is equal to 4, really? I have to confirm this. I have to confirm if this is correct. So that is not correct. That is 400. That is 400 pounds per foot. Okay. Dead load is 400 pounds per foot. Roof live load or rain load is equal to 270 and W is 300. So there are three given loads, 300, 270 and 400. This is 400. So this is a typo error. 400 pounds per assume that wind can be plus or minus. I always do that assumption to be cautious about it. So let us solve. So equation number 1, it is only dead load, so 400. Equation number 2, dead load plus live load. There's no live load, so 400. Okay. So what else? So let me see the equation. So equation number 3, dead load plus roof live load. So dead load is 400 plus roof live load 270 is equal to 670. Okay, then equation 4 is dead load plus 0.75 live load plus 0.75 roof live load. Okay, so .75 dead load plus 0.75 roof live load. Okay, so since that is roofing, there is no live load, no? Roof live load, because that is roofing. The usual, that is the usual. There's no live load in the roof. Okay, that is the usual. But anyway, if there are designed space for party in your roof, so that is a special case. But usually, there is no live load in the roof. So only roof live load. Okay, so that is equation number 4 and equation number 5. Equation number 5 is dead load plus 0.6 wind load or 0.7 earthquake load. So let us do both. Okay. So 0.6, we do not have a given earthquake load. So that's why for equation number 5, we only need to calculate dead load plus 0.6 wind load. So that is equal to 580. Okay. And then formula equation number 6. So let us look for the number 6 formula. Letter A, dead load plus 0.75 live load. So there is no live load. So therefore, plus 0.75 wind load, we have that, and also 0.75 roof live load. So there are three terms. So dead load plus 0.75 times 0.75 times 0.6, okay, times 0.75 times 0.6 wind load, okay, so that would give us 737.5 pounds, okay. So 0.75 here and times 0.6. So always in ASD, wind load is multiplied by 0.6. Take a look at equation number 5, equation number 6, and equation number 7, I think. Okay. So, and letter B, dead load plus 0.75. So, dead load times 0.75. What? Live load plus 0.75 times 0.7 E or earthquake load plus 0.75 S. So, what is that? What is the amount? So, live load times 0.75 and plus dead load. So, again, if you compute that, what will happen is 400 plus 0.75 times 270, that is 602.5. Okay. And then, number 7 equation is 0.6 times dead load plus 0.6 times wind load. So wind load is negative, so therefore the dead load negates the effect of wind. Oh, that's good. That's good for the structure. Okay. And equation number 8, that is 0.6 dead load plus 0.7 earthquake load. There is no earthquake load, so immediately 0.6 times 400, that is 240. Okay. So all in all, if you compare the 9 result, we have 9 result, comparing them, which one is the highest? So we have 737.5 pounds per feet. So since we are now going to use this as our final answer, we just need to use this as 4 significant figures, okay, for a final answer. Okay. But if we continue to use this as an input, we can use this as 4 significant figure, and the dimension, the design, the analysis would be the 3 significant figures. So something like that. We will always do that computation policy. Okay, so let's have a shout out from Xavier Jokic. Thank you for attending this lecture. Also for what shout out to Family Hayes. I think they are from Europe, France, flag of France. That is a flag of France. Okay. And that would be our last slide for this module, and this constitute the whole discussion on ASD combination of loads. Again, for the comments on your challenge question for material engineer exam, question number 11, what is the ratio of mortar use for grouted riprap ratio. This is a ratio of mortar for grouted riprap Portland cement is to sand. A 1:1, B 1:2, C 1:3, D 1.5 is to 2.0. Again, this is your Professor Dr. AP, preaching engineering for nation building.